Welcome to Tramlines, a podcast from Agri. I'm your host, Tony Smith, putting your questions to the experts. In this episode, I'm talking to Professor Andy Neal, soil microbiologist from Rothamsted. He is currently focusing on a major project called Soils to Nutrition. And today we're going to explore what do we mean by soil organic matter and why it is so important to understand what is influencing the availability of nutrients and water in our soils. So, good morning to you, Andy.
Hello, Tony. How are you?
Yes, absolutely fantastic. And it's great to speak to you at long last, actually. We've been trying to arrange this podcast for a little while, but I know you are in such demand and very busy at the moment. So the question I'd really like to ask you is Soils to Nutrition. This is the project you're working on. Well, what is the latest science behind how soil works? Could you share that with us?
Sure. So the Soil to Nutrition program really stretches across the whole range of food production from the soils and the microbiology, then organic matter in soil, all the way up to nutrition of the foodstuffs that are produced on farm. My particular area of expertise and interest is understanding what's going on in the soil, particularly what's going on with the microbes in the soil and how organic matter additions to those soils effectively influence the way that microbiome, as we call it, that's the collection of microbial communities in soil, how that microbiome metabolizes and performs, particularly so that we can use it or perhaps manipulate it for even more efficient agricultural production. So one of the key things we're seeing, and actually we're slowly developing a new theory of how soil works, is that the amount of organic matter put into soil is critical for a number of really important facets of soil, particularly in controlling how the microbiome metabolizes and respires, and that's really important for nutrient use efficiency in soil. But also, the organic matter contributes and is critically important for the formation of pore structure, and that fine sort of what used to be called a lovely tilth, that sort of soil structure that we know is associated with water holding, high water holding capacity and high resilience of agricultural soils. So my little area is right the way down the bottom, but the Soil to Nutrition program stretches all the way up to foodstuffs coming off farms.
And Andy, when you talk about the microbiome within the soil there, how does that influence the availability of nutrients?
Well, the link starts with the fact that when you add organic matter to soil, usually as large particles effectively, it needs to be broken down. And of course, we're well aware that there's a group of organisms called shredders that are basically chew that organic matter up. But the critical step is when it gets down to the size that microbes, and we're talking about fungi and bacteria and a group of bacteria-like organisms called archaea. They are the ones that critically turn that over. They turn it into biomass in the soil, so they help fix that organic matter and minerals associated with it in biomass. And that's very important because if it's fixed in biomass, it's not lost from your system. But critically also, they turn over that organic matter to the point where it's small enough to start interacting with mineral particles in the soil, particularly clay particles. Once it's down, once these small molecules are interacting, effectively sticking to clay surfaces, they start to act rather like a cement. And so they then stick other clay particles to that clay particle. You start getting this snowball effect of structure being created. So the first step is really that turnover of that organic matter into molecules small enough to act as an adhesive to stick the particles together. Now, once you get that going, you start to get the creation of pore structure. Now, pore structure is critically important, and it's as critically important in soils as road networks are to a good functioning human society, in the sense that soils that have a high degree of pores, which are very highly connected to each other, allows, first of all, the storage of water. So that's where your water storage capacity comes from. And particularly in pores of about 100 microns or less, they're the sort of pores where when water drains out of a soil after a rain event, capillary action holds water back against gravity. So those very small pores, and they happen to be about the same scale that microbes are functioning in, are critical to your water holding capacity. So getting organic carbon into your soil directly affects your water holding capacity if you have a sufficient clay content in that soil. Once that's occurred and you've got a nice pore network, that allows oxygen to move through the system as well as water very effectively. Now that's critically important because that oxygen controls the way in which the microbial community metabolizes. In very poorly connected soils, where oxygen is very difficult to move through the system, microorganisms are very capable of switching to anaerobic respiration processes, and they do that largely by using any available nitrate they can get their hands on, or hands get their mouths around, and their respiratory activity turns that into nitrous oxide. And of course, that's firstly a very potent greenhouse gas. Secondly, that loss from your agricultural soil is a real issue when it comes to nutrient use efficiency. So there are clear links between adding organic carbon in whatever form at the beginning of that process directly through to the way in which the soil respiration occurs and the loss of expensive nutrients from your system, which will never get to the plant or will just disappear out into the atmosphere.
So just going back to a couple of points you made, and I'm sure listeners are already coming up with loads and loads of questions for you. Just to clarify, when you talk about different sources of organic matter that a grower can incorporate into that soil, just clarify what principal types or sources are you thinking about there?
Well, I'm thinking about anything from farmyard manure to green manures, compost. And now we even have sort of digestates coming out of bioreactors. So the long argument in the UK has been that there's too much organic matter in the West and too little organic matter in the East. And somehow we need to balance that problem. And part of that is looking at these we call them alternative, but it's basically just organic matter when it comes down to it. So what's coming out of bioreactors and the potential for green manures in fields. So I don't think there's anything particularly special about what we put into our soil. If it's organic, it's going to be having an effect. And now, of course, there are issues to do with carbon and nitrogen ratios, but ultimately, organic matter is always going to be good for soil.
Yeah, and I've certainly heard that in earlier podcasts, both farmers and agronomists talking about the West having an easier sort of opportunity there to get organic matter onto the farm. So that answers that very well.
Sure.
What about those farmers that have soil types on their farms that don't have a very high clay fraction? What does that mean for them?
So that's a very good question. And actually, I think it's one of those areas of soil, especially as we're moving to the potential of paying farmers for sequestering carbon. It's one of those areas where there's a lot of misunderstanding, I think. Probably not from the farmers that are having to cope with their sandy soils, but from the more general understanding of how we can sequester carbon. The fact is that in sandy soils, it's very difficult to sequester carbon, large amounts of carbon.
Right.
Most of the carbon that is put in remains available for organic breakdown, so microbes can access the carbon that's put in there very effectively. There are no clay particles to stick organic matter to and effectively hide it. So most of the organic matter that goes into sandy soils is lost to the atmosphere. Now that means from a practical point of view, anyone trying to sequester carbon in very sandy soils is on a wild goose chase effectively. And secondly, it may be very difficult for them to demonstrate that their good practices are actually having a beneficial effect on organic matter in soil. Again, it critically comes down to the capacity to effectively lose carbon in soil. You've got a lot of clay that can sequester and hide that organic matter from microbial breakdown, then you get good sequestering potential in your soil. You don't have a lot of clay, very little of that organic matter can be hidden from microbial activity, and most of it is respired and lost to the atmosphere. So understanding and also having an appreciation for that as we move into new ways of funding and supporting farmers for doing community or collective goods is going to be very important, and understanding organic matter in those soils is going to be critical to understanding how nationally we should be managing our organic matter stocks in our soils.
Yeah, and relating to that, there was a question that was sent to me earlier on before we did this podcast. And the question is, in terms of bringing that all together with that question, the term soil health was only coined some 20 odd years ago. How would you now define what soil health means? There's a question for you, Andy.
Well, it is, and it's a difficult question to answer. Of course, I'm going to have a go, but it's a question because even with human health, it can be very difficult to really qualify what we mean when we say human health. You know, when is a person healthy and when are they not? And in soil, where we understand so much less about the whole system, it becomes even more difficult. My view of soil health as a microbiologist or as a biologist is based upon biological activity. So my understanding would be a diverse ecosystem. So that's a environment or a soil that has a wide diversity of different types of organisms doing different functions. The reason why I think that's important is because it gives you resilience to your system. So it means that as the environment changes, as it goes from a very hot climate to a very cold climate through the seasons or the other way around, the organisms are there that are capable of maintaining certain functions in soil. So that's one measure of health. Another is this whole pore structure and pore connectivity issue. Healthy soil will have lots of pores, and they will be very highly connected so that nutrients and oxygen can move through the system very effectively. That means that the whole system is driven predominantly by oxygen, and that's where nutrient efficiency derives from. It's really the assimilation of those nutrients into biomass that are turned over, but rather than being leaky, are turned over into new biomass or make it to the plant. Where we have very unhealthy soils, where they're not very well connected, lots of anaerobic processes is where we lose nutrients from the system. So that's another way of looking at how biology fits into that health concept. But of course, as we've just said, if you were to use just those definitions, every sandy soil is not healthy. And that can't be the appropriate way to think about soils. So sandy soils are also healthy in the sense that they flourish and there's a microbial activity going on, but it may not be exactly the sort of health that we want when we're growing food. So this is why I find the soil health concept so difficult. What does it mean? Does it mean that we castigate a whole load of soils as unhealthy right from the get-go? I don't think that's fair. I think we need to see that sandy soils are healthy in a different way and perhaps should be used for different purposes other than growing food. But so it's a very difficult question to answer, soil health. And in many ways, I don't think it's helpful that we spend so much time worrying about what soil health is. We need to understand what the fundamental properties of soil are that we need to grow our food most effectively.
Very interesting. If we can move on to the big topic of the moment, which is regen agriculture. And I actually noticed that you've got a fallow trial that's been in the ground for 59 years. So what are your views on the impact of different tillage systems and mechanical activity on these soils?
That's a really topic. I've just come back from Groundswell, so I've been immersed in the whole regen ag thinking. So I do promise you, these are my own thoughts.
That's good.
That bare fallow treatment you talk about is really interesting. And again, if I can just go back to soil health a little, one would think that soil is not in a healthy state, and yet the microbial communities there are functioning very well. They function in a different way to the systems that are under pasture. But as a microbiologist, I wouldn't necessarily say they're unhealthy communities. They're still diverse. They're still functioning, which suggests that they're extremely resilient because they've not had any plant inputs for 40 years, 50 years. Coming back to the whole concept of tillage, soil disturbance is a real issue. And it's a fine balance to strike, I think. I think I understand that under certain circumstances, it's critically important that soils are tilled and physically disrupted. But we have to understand the consequences for that. And I think we are starting to understand the consequences for that. A lot of farmers are thinking about, do they need to till? Can they adopt no-till practices? But what we know from research is that I was talking earlier about how we can sequester carbon in soil by effectively locking very small organic molecules onto clay surfaces, which then act as glue. So in a nicely structured system, you've got a lot of organic carbon hidden from microbial activity because it's forming effectively the cement that's holding everything together. Of course, when you start tilling that soil, you break a lot of that structure open again. And a lot of that stuff that was hidden becomes available for microbial activity. So when you plow your soil, you liberate a lot of that organic carbon from microbial activity. You get these bursts of carbon dioxide coming out of the soil as a consequence. So there's a direct link between tilling your soil and losing organic matter. Now, it may be if you've got sufficient carbon to replace. I mean, if you think about sustainable systems, the whole concept of a sustainable system is that you never take out more than you're putting in. If you want to till and you have a lot of organic matter in your soil, you could probably, and actually work on the broad book experiment at Rothamsted suggests that where you can add an unrealistic 35 tons per hectare a year of a farmyard manure, you can till every year. You can use winter wheat practices for 170 years. And the structure that we're concerned about, so this 100 micron and smaller pore structure, is equivalent to what is in the neighboring pasture that has never been plowed at all. So we know that if you have enough carbon to hand, you can overcome the effects of tillage down at these pore scales that's important for water holding capacity. But most people don't have that much. I mean, Rothamsted is a rather unique and long-running and unique set of experiments. So we would not expect that most farmers can put their hands on 35 tons per hectare of farmyard manure. But what we can show that were you able to do that, you can overcome the effects of tillage. Given that most farmers can't do that, they have to think carefully about, do I need to till? Do I understand the consequences of that tillage for organic matter in the soil and the structure that is driving the efficiency of nutrient use? And how can I correct it? Is there a way of correcting it? And typically, like I say, organic matter, including some form of organic matter in your rotation, in your nutrition or fertility management, would be one step to limiting the effects of that tillage on soil structure.
If we as growers, as agronomists, can actually really focus on soils in this different way, the upside of it is that it's better for the environment and there's a real upside for crop performance. Have I got that right?
Yes. We seem to have lost over the decades this concept that soils are part of the carbon cycle. That, you know, and there's more carbon stored in soils than there is in the above ground plant matter. It's a very important repository for carbon in a natural system. As technology has provided alternative ways of nutrition for plants, the whole carbon bit has been forgotten. And I think we now are understanding just how critical it is, not only to water holding capacity and soil structure, but also to the whole way that soil respires and metabolizes nutrients. And the concept of having these very tightly coupled pore networks, which are holding nutrients in the system rather than letting it leach out the bottom or disappear out into the atmosphere because of poor structure, very little oxygen. We understand that organic matter is critical to creating those sorts of nutrient-efficient agricultural systems, but also that you can only do it on the right sort of soil.
Well, thank you, Andy, for sharing your research and scientific understanding of soil to nutrition. Well, that's it for this podcast, but do tune in again as we meet the experts throughout the season, exploring the many immediate and longer-term questions for growers and farmers in the UK. If you have any questions, of course, that you'd like us to ask the experts, email info@agri.co.uk. See you next time.